Assalamu alaikum and welcome to the Voice of Islam Living History program. I'm your host, Dr. Mohammed Iqbal, and in this new series of Living History programs, we're going to look at some of the most important issues and personalities that have shaped the history of mankind. In the first of two programs, we're going to look at the origins of mankind and the universe, some of the beliefs and the theories that have been around that have helped us to understand our place in this universe. Let me just start off with giving a little bit of background to this program. I think most listeners will agree that the majority of people on our planet, for them, religion is still the predominant influence over the conduct of their lives. Intellectually, for the greater part of human history, men and women, of course, have turned to religion not only for moral guidance, but also for answers to the fundamental questions on the origin of life and the universe. However, we live in an age where reason and the conquest of science and technology claim to provide logical answers to most of the great questions asked by the human intellect, and religion has had to take a sideline. Many scientists hold the view that the world's major religions are founded on received wisdom and dogma rooted in the past and do not cope easily with changing times. It is argued that objective analysis is lacking in the study of religion. So, in this two-part series, we're going to look at how our thinking has changed over the many thousands of years from a religious perspective to a scientific perspective. I'm joined for this series of programs by Amjad Hussain and Arif Ahmad Saab, our local experts on a variety of historical issues. And we're going to explore in the first program really some of the ancient beliefs and views. So, Amjad, if I can start off with you. A lot of people talk about cosmology in relation to understanding our place in the universe. Just tell us a little bit about what you think or what people think cosmology is and how it tries to tackle these issues, both from a religious and intellectual scientific point of view.
Cosmology is old as humankind itself, and some sort of cosmology has always existed since time immemorial. And of course, it was based on a combination of religious ideas or mythological and esoteric traditions and various creation myths of our ancestors. Once primitive local groups developed language, it was a short step to making their first attempts to understand the world around themselves. Very early cosmology, for instance, say from Neolithic times, from 20,000 to 100,000 years ago, was extremely local. The universe was what you immediately interacted with. Cosmological things were weather, earthquakes, sharp changes in your environment, etc. Things outside your daily experience appeared supernatural. So basically, the scholars have come to call this particular time in our human evolution or development as magical cosmology or magic cosmology, because things appeared magical to us. And for instance, the clockwork of the rising of the sun and the setting of the sun, the moon and so forth. So these cyclical things, they much observed that, the patterns kept repeating, the weather patterns and so on, the four seasons, depending where you were on the surface of the earth, of course, your location and so on. But however, various cultures we find that are far remote, thousands of miles apart from each other. Say, for example, the natives of Amazonian jungle or the aboriginals of the Australian outback. They will have qualitatively different experiences from that of, say, for example, Easter Islanders. However, each culture may come to explain the creation in its own terms, related to its own local set of circumstances and environment. Interestingly, however, it is observed that these cosmologies should be, different cosmologies. But rather what we see is commonality of themes, symbolisms and storylines expressed obviously in distinctly similar terms and organized according to a set of familiar, stages of creation. So we find some common themes, current themes in all cosmologies.
I'm going to explore some of these ideas, but just turning to Arif, it's interesting. I was reading an account of a lecture Stephen Hawking was giving, because obviously, in terms of explaining the universe, he's one of the most prominent figures. And he starts his lecture by giving this tribe from Africa how they tried to explain. And this is about primitive societies. I can't remember the name of the god they have in there, but he says he woke up one day and he had a terrible tummy upset, and he vomited the sun one day and the earth another day, and then things dried up on the earth and whatever. But these are all primitive things.
Yes, I mean, I think one of the things, one of the terms used as part of cosmology is mythology. Yeah. And myth basically means stories. And I suppose this is early man's attempt to try and understand the world around them. And obviously over time these become exaggerated, people add them, try and make them more interesting. But there is a lot of commonality. I mean, if we look at one of the theories, for example, Hinduism, which is obviously the oldest practiced religion, still to this day, goes back to about 5000 BC. If you just read a little bit about, their idea of creation, according to them, Lord Brahma is the creator of the universe. But there are two other gods involved, Vishnu, who sustains creation, and Shiva, the destroyer of evil. And these three gods are one supreme being who is behind all creation and destruction. And they create and they destroy universes continuously. So, this creation and destruction, I'm sure this is something that we're going to come on to talk about when we look at the scientific aspects. But that's quite interesting as to why they think that gods would be creating and destroying universes. Also, the length of time of such a process is unaccountable. But Hinduism believes that one day for Brahma is considered 4 billion years for us. So again, this concept of time, one day doesn't mean one day in the modern sense. It could mean an indeterminate amount of times. They also believe that Brahma creates all human beings and life, and all different species come out of parts of Brahma's body. So this is again tying in with what you were saying, that there's a God and from his body life is created. And there isn't maybe one unified theory in Hinduism, but they can see that there are, supernatural beings. And one of the other interesting concepts that I heard about Hinduism is that they think that the universe maybe came first and that gods came afterwards. So, that's very interesting to think how the universe would come before God, because that seems very, very counterintuitive. So these theories have been developed and manipulated and changed maybe over time, but there are a lot of commonalities, I said, about God's creating.
It's interesting, Amjad, isn't it? We're going to take our, hopefully, listeners on this journey of how our thinking and our ideas have shaped. But here we are in the 21st century. And, Hinduism still has such a large following with ancient scriptures, etc., explaining many people clearly. There are, great thinkers amongst the Indian population and Indian culture, modern scientists, great Nobel Prize winners, but an idea that holds. But a lot of these were also held in the Middle East and in Christian Europe as well, where the story has slightly changed. So to just take us through of some of the variations and different ideas, Amjad.
We get, Arif has just alluded to, from cosmology, from Hindu point of view, from physical evidence of astronomy and astronomical and cosmological thinking, we find that it's found in the lunar calendar, which was found on a bone fragment in the sub-Saharan Africa. And that is, obviously, we can date bone, which is or has organic material, and that's dated to 20,000 BC. So humans around that time documented the cycles, the lunar cycles and so on, as I previously alluded to. And we also find now there's been discovery in this last decade or so of another henge. It is known as, it's a type of a henge. Everybody's familiar with Stonehenge and so forth, but there's also another henge on the in the Anatolian plateau, and that was deliberately buried for a long time. And now the archaeologists have found it, and it's called Göbekli Tepe. So if somebody wants to search it, it's in southern Turkey, and it was built around 11,000 years ago. And the site consists of series of at least 20 circular enclosures, and what they found is that basically this temple or site was built to worship the dog star. The dog star, to our listeners, is basically the star Sirius, the rising Sirius. So basically, this was really around the Neolithic period, as it were. So before we come on to the Hindu mythologies, these mythologies have also existed. So basically they used the henge and these megalithic stones to basically lay an image of these various stars, constellations, and we find that there's another tribe in Africa called the Dogon tribe, and their mythology and creation story and revolves around, again, about the Sirius star. So they're two completely different cultures, geographically thousands of miles apart, have the common theme, recurring theme. And just before, we know we're going to come back to this, but the Holy Quran, it is said that there isn't a community to whom the Lord has not sent guidance. And of course, since time immemorial, mankind have never been without guidance. But what, however, has happened is that there has been corruption of ideas, corruption of unity, and so forth. And of course, we're going to take up these themes later on. But it is interesting to know that these creation stories, when we peel back the layers of myths and mythology, we find there are some common themes. And we're going to talk a bit about these tribes in Africa. And we find that these tribes, obviously, they do have emphasis on the unity of creation, as it were.
It's interesting whether we look at religious scripture, religious texts, or some of the recorded history. For most of mankind's recorded history, we have been led to believe that we as humankind are special and lie at the heart of the universe. Some of the greatest philosophers of the past believed that the sun and the rest of the stars moved around the earth, for example. But today we know for a fact that this is not true. We humans live on the third planet from the central star, our sun, and all the 9 planets in our solar system rotate around the sun. And I want to really explore how we got to this point and the knowledge that we got, and really the biggest impact on our thinking in relation to religious viewpoint and scientific is from the Judeo-Christian traditions. I'm going to deal with Islam in the second part of the program, but from the Judeo-Christian traditions, Genesis, the Bible, in fact, starts in the beginning, doesn't it? So just take us, Genesis very much puts man and earth right at the center of everything.
Yeah, I think many of us will have, obviously, if you've studied RE at school, Genesis is one of the things that you read and that you study. And there's two very distinct but very important aspects which are covered, two creation stories. The first is, I think it's called Elohim, which is that about God creating the heavens and the earth in 6 days, and obviously on the 7th day taking a rest. So that's, even to this day, Jews and Christians would believe that the 7th day would be a day of rest, and the 6 days reflect the 6 days that you're working, but these 6 days are the days in which God built the earth. Now, obviously there's much debate about what a day is, how long a day is, and whether that day is the same as what we recognize as a day. The second story is based on the personal name Yahweh, which is the story of how God creates Adam, the first man, from dust, and puts him in the Garden of Eden, and obviously Eve is created from Adam and becomes the companion. So we see this very, very basic story that probably most of us, and I think everybody in the world would have come across this story. But there's a lot of symbolism in this story. There's a lot of detail. I think, as Amjad Sahab was saying, that you have to sort of dig down to get to the bottom of this to really try and understand it, because over time, again, people have changed the story. For example, is Adam, as in the Bible, the very, very first man, Muslims would believe him to be, for example, the first prophet. And then even, was Eve really created from Adam, or was it just a way of describing that Eve was a different type of creation, a female companion to Adam? So I think, it's important to understand this story, both in terms of its symbolism and also its impact on how we believe that man has evolved.
It's interesting, as you point out, when you look at Genesis chapter 1 and chapter 2, they talk about the universe and mankind's origins, etc., but they're written from very different angles. And as you say, in chapter 1, it goes through a series of events in terms of creation of the heavens and the earth, and the light and the darkness, and day and night, and water and dry land, etc. And in the second chapter, it goes to specific, really, the creation of Adam and Eve. And interesting, when you break this down, Amjad, maybe you could shed some light in it. The two accounts are written at very different time points. My understanding is that the second chapter, apart from the first 4 verses, is a lot older of the two accounts, and it dates from 950 to 850 BC. And as Arif said, it's from the Yahwist version, and then the second, the priestly version, is about 400 years later, and in a sense, they reflect the civilizations that the writers of the Bible came across, aren't they? And this is quite common when you're writing scriptures and trying to define word of God exactly. What did God say, what he did, how he did it, etc.?
We know that the Israelite tribes, when they were Canaanites, whom the cities they took over, we know they've been wandering in the desert and they were in Egypt. But before that, we know the patriarch Abraham comes from the tribe of the Chaldees and is Babylonian from the city of Ur. And of course, we know at the time of Prophet Daniel, and well before that, time of Nebuchadnezzar, the first temple was desecrated, it was smashed, and the Jews were taken into captivity and taken to Babylonia. And what we find in the Torah, for instance, the Genesis account, is very much, if the scholars and if all of us to look at it with a very cool head, we'll find that a lot of similarity with the Babylonian and the Sumerian creation myths, as it were. So what we find in the Bible is pretty much, the creation story of the Babylonians and the Sumerians, so forth. And it may well be that the Abrahamic and the creation story got incorporated because when the Jews were in captivity, and we find that now the scholars, even the Judeo-Christian scholar, admit to this, that the Bible, the Old Testament has gone several revisions, as it were, and I take it this is what you were alluding to, and one cannot rule out the inaccuracies that we have.
It's interesting. When I was doing my PhD, one of my favorite books outside my research was Professor Ninian Smart's his book Mankind's Religious Experience, and he writes, this is in relation to how the Babylonian civilizations and the Assyrian civilizations influenced the writing. He says, Gilgamesh obtained the secret life-giving plant but was robbed of it by an accident. Adapa too was tricked of this blessing. What is characteristic of the story of Adam, in brackets he writes, meaning man, he stands as the symbol and embodiment of the human race, is that the fall occurs through a mysterious moral choice. Man was destined for a life in harmony with God, but in asserting his independence, he became alienated from life with God. And this is about Adam and Eve and how the serpent, came into it, and it just shows the interaction, doesn't it?
Yeah, and I think one of the very interesting aspects of this is that, for example, there are many Christians who maybe don't take the Bible to be the literal word of God. But there are significant minorities who say that everything in the Bible is literal and should be taken word for word. And obviously they will use the story of Genesis to completely refute the theory of evolution. They will say that this is how God created the world, and it's all being laid out in Genesis, and so the theory of evolution, doesn't come into it. Now, if you read the actual biblical account, and as you mentioned, Dr. Zab, the 6 days could relate to 6 phases about how the world. So it's interesting at one aspect to see that whoever has written Genesis, evangelical Christians believe it would be God. Other people might believe it's been revised. But there is a lot of commonality there between how scientists understand the world has developed or evolved. And it's just the slant that you put on it, whether you take everything literally or whether you take things to be allegorical and to be, symbolic. But as I said, it sometimes creates this conflict between, no, this is how the world was created, compared to how maybe Darwinism has said that the world has been created.
And it's interesting, isn't it? When we look at the biblical accounts, up till only a few decades ago, many people in America, the evangelicals, still believe the Genesis account rather than whatever Richard Dawkins or anybody else may want to say. The civilization was only around about 4,000, 5,000 years ago. There was a Bishop Usher, I think his name was.
Yes, Irish Bishop. Yes.
Who actually calculated to the exact day of when creation took place.
Yes, of course, that's very interesting. Again, I think he was a literalist, so to speak, just to emphasize what Arif. They're literally literalists who take these things in the Torah and the Gospels, in the various creation stories, and of course in the Genesis account as well, literally, and then they work backwards, and they say, well, 5,000 years ago, that's when the whole universe came into being, and Adam was in, and so forth. But to contrast that now, because we have physical evidence, we have probes that we sent into the sky. And, the famous one is called the W map, and we have the up-to-date results, which came about only in 2012, only 6 years ago. It's called the NASA's Wilkinson Microwave Anisotropy Probe, or WMAP, and that estimated the age of the universe to be around 13.772 billion years, with a uncertainty of 59 million years, I beg your pardon. And of course, physicists have theoretically calculated the age using physics and equations and maths, and we worked this around 13.8 billion. So can you imagine 13.8 and 13.7 what we get from observational data? And of course, we also, that's how old the universe is, or the cosmos is. And we know, using the same probes, we worked out, and this is observational data as we speak, with all telescopes in the infrared, in the visible region, in the microwave, and the X-ray region. The Milky Way is around 13.5 billion years, and the age of our solar system is 4.5 billion years, and the Earth is, using geology. Geology tells us, and plate tectonics, and it's around 4.5. And we know the origin of life is 4.6 billion
this is
years.
the interesting bit, isn't it? Because when you look at from a religious angle, you say 4,000, 5,000 years ago, and science telling us 13 to 15 billion years ago.
One of my favorite stories, and not wishing to offend anybody, but an American comedian was talking about this very subject, and he was saying, how do the evangelical Christians explain fossils? Because obviously you can date fossils and you can see, and the answer that some of them gave him was, well, fossils were put there by God to test us. So they'll always find a way of countering, even though the scientific evidence is there, and it's pretty obvious to any rational human being, but still it shows how literal people are prepared to take these accounts of creation.
Interesting thing is, this is obviously from the biblical narratives, etc. But I want to touch on another important philosophical input, and that's the Greeks. Because clearly, Western culture has been influenced massively. Not just Western culture, I think Islamic culture also. Really, they were the inheritors of the Greek Roman culture. But share with us your thoughts of how the Greeks contributed to our thinking about the cosmos and how we came to being, because one of the giants of philosophy and thinking was Aristotle, but Plato also had quite interesting view.
Plato has written, on philosophy, on politics, and so on. But obviously, the Greek, did not evolve their thought in, independently. They inherited much of the cosmologies from early Egyptians, from the Babylonians, and actually, the Babylonians were the first astronomers, and we do have their written records, which anybody who can understand cuneiform can go into a museum who have well-equipped museums of Syriology and Babylonia. It's around 750 BC. They discovered the 18.6 year cycle, the rising and the setting of the moon, and from this they created the first almanacs, the tablets of movements of the sun, the moon, and the planets, and which are used also in astrology. And around 6 BC, the Greeks obviously developed further on this knowledge of the ellipses and so on. And it's actually before we come to Plato, there was somebody called Thales of Miletus. He predicted the solar eclipses and so on, and they used the zodiac. So Plato, of course, founded the school, the Platonic Academy, and this really, has much influence the current thinking that we have, which basically brings on to the heliocentric or the solar-centric or the earth-centric and heliocentric things that, basically the Arabs then subsequently developed that, and then we'll basically in the next...
one of the interesting thing was that the Greeks essentially believed in an eternal universe, that it has existed forever. And also the Hindu philosophies largely believed in an eternal universe as well, that it had existed forever, ever, and we're going to touch on that in the second part of the program of how views differed and how they changed over time as well. And of course, we're going to have to tackle the great figure of Aristotle as well and what his views were. So let's head towards a break. And before we go for a break, I need to remind you of our Twitter handle, because we really value your feedback as listeners to what you think of our program. So our Twitter handle is at VI Living History. So do please give any feedback if you like our programs, and we'll greatly welcome them. So we'll catch up in the second part of the program.
Allah, Allahu Akbar, Allahu Akbar.
You're listening to the Voice of Islam Radio, broadcasting on DAB and via the internet 24 hours a day.
Welcome back to the Living History program. We were talking about the contribution of the Greek philosophers to our understanding of the origins of the universe and mankind, and we were just talking briefly about Plato's contribution. And Arif, you wanted to make a comment on what his views were?
Yeah, just one small point, that Plato also considered non-physical forms. So obviously everybody could see what was going on. They could see the earth, they could see the sun. But Plato had this interesting theory of forms, and this covered physical, what we could see, and also non-physical. And this was his way of sort of taking the theory further and thinking, well, it can't just be what we can see. There must be a lot of other stuff that we can't see, or some other presences or things that are not visible to the naked eye, and they must be forming a part of the world and be involved in creation. So it was good, because obviously that was then used and developed by other scientists in terms of forces that we cannot see but which are important in the world in which we live.
The understanding of the cosmos in the West in particular, and also in Muslim lands, which inherited really Greco-Roman knowledge really, was dominated by the giant figure of Aristotle. Amjad, do you want to take us through what his view of the universe was and our place in the universe?
At the center of the universe, what Aristotle believed was the central fire, and then everything surrounded this cosmic central fire. And obviously, as far as our solar system was concerned, he believed in geocentric, static, steady state, fire, finite, that extended thing, solar system. And he believed that the spherical Earth was surrounded by concentric celestial spheres, and universe existed unchanged throughout eternity, and it contained the fifth element, which he called ether, and that was of course added to the four classical elements, as we know, the air, the earth, the fire, and water. So that was basically Aristotle's version of the universe. And then what we have is basically moving on from Aristotle, that was around 300 BC, to Ptolemy. And the Ptolemaic model was that, again, of course, it was geocentric, based on the Aristotle's version of the universe, but they extended a bit more. And the Ptolemaic model says that the universe orbits around a stationary Earth. Planets move in circular cyclical motion, each having a center that moves in larger circular orbits, what he called eccentric or different, or in a differentiated way around a center point near Earth, and the use of and what they did was basically they added another level of complexity and allowed astronomers to predict the position of the planets. And the most successful that was basically at that time the most successful model of the universe, and this basically is what we get in the book that it was published called the Almagest.
Interestingly, whilst Aristotle was a giant of a figure who advocated an eternal universe that has existed forever and ever, with the earth being at the center of all this. In the Muslim lands, where we had some of the greatest philosophers that mankind also saw, there was a lot of discussion and debate about whether the universe was eternal and whether it had a beginning. And there was this battle going on between the Kalam cosmological proponents and the Falsafa proponents, and you had people like Al-Ghazali, Al-Kindi, sort of saying that, and Saad, a Jewish philosopher by the name of, I think, Saadia, saying that there is a beginning. And then you had Ibn Rushd, you had Maimonides and Thomas Aquinas and others saying that, no, there's an eternal universe. And it seems that when it came to Western Renaissance, and we'll talk about really the developments from Renaissance onwards, the eternal universe people, the philosophers' view, won the day. And so we inherited this view of an eternal universe, but with the earth being at the center of it. And then in 1543 came a shattering blow from a Polish mathematician called Nicholas Copernicus, who published a book called On the Revolution of the Celestial Spheres. Basically, he said, sorry, folks, the Earth is not at the center of the universe.
Just before Amjad talks us about that, it's very interesting to know how important man thought he was. Nowadays we know how insignificant the Earth is in the cosmology, yes. But at that time, people were probably thinking the Earth is important, we're probably the only people that exist, and everything revolves around us. And it's interesting to see how this theory has changed both philosophically and scientifically, that people have realized obviously our existence is pretty insignificant, we're not anything special. And I think Copernicus, was one of the first people that really demonstrated this in practical terms.
Well, it's quite a revolution, I think.
Oh, absolutely, because Copernicus said, well, he observed, these the five naked eye planets that we know them, Mercury, Venus, of course, we are on the Earth, and then Mars, Jupiter and Saturn. And these were known to the ancients as well, of course, and they were named after the gods. But they came to realize that when you looked at one of these planets, say Mars or Jupiter, for instance, it tends to, it should be basically going, its own way in the orbit in a linear fashion. But there was an occasion when it went back on itself. It's what they call the retrograde motion. So it went back on itself, and nobody could explain that. And Nicholas Copernicus came with the idea, and there were, of course, others in the Middle East as well. So the Muslim astronomers suggested that actually, because we happen to be on the Earth, and when we look at this planet, because we are innermost, and if you look at the wheel that we have today, for instance, so if you are on the innermost of the wheel, you're going faster, and if you are on the bit like the merry-go-round, if you are on the outer thing, you tend to be going slower. So basically, if you are on the merry-go-round, and if you're on the basically in the center, you'll be traveling twice as fast as the one on the outside. So this is actually the same motion with the planets, and he came up with the idea that the Earth we are on the earth, and basically it's not the sun, we are not the center of the universe. It's basically the sun that is the center of our solar system, and planets are the ones that are going around it. And of course, subsequently, we know with Galileo, he had built a telescope, and when he looked at the planets, and obviously now we just don't have speculative data, we have observational data.
I mean, this is when the Catholic Church really started panicking, when these scientists started opening up new horizons, new views. And Arif, Galileo clearly played a major part, and I think he didn't pay as heavy a price as Bruno, but go on.
Well, just before Galileo, Giordano Bruno, who was a mixture, actually. He was a friar, he was a philosopher, mathematician and poet, and he had lots of theories about cosmology. He actually, I think, extended the Copernicus model, and he said that, for example, stars were just distant suns, and they had their own planets that circled the stars. But again, he was also one of the ones that believed that the universe was infinite and that there couldn't be one celestial body at its center. Now, obviously,
but he certainly didn't believe the Earth to be central.
He didn't believe the Earth to be central,
didn't it?
Absolutely. And of course, this challenged the Catholicism and the Catholic doctrines. I mean, he challenged many other of the doctrines, for example, the divinity of Christ and Trinity. So obviously, he was very much in the bad books. And I think what was developed by the Catholic Church was inquisitions, the Roman Inquisition. And obviously, he looked at the evidence and he didn't want to go back on what he had said. So unfortunately, he was actually killed.
He was burnt at the stake.
Burnt at the stake.
Burnt at the stakes, yeah.
And in a way, he became one of the first martyrs, literally a martyr for science.
This is why Richard Dawkins can't forgive the church, unfortunately. We have this ongoing battle.
Yeah.
But also, no, you want to finish with...
Well, I was going to say that obviously then he was an influence on Galileo, and I suppose Galileo is much more of a modern, much more of a renowned name that people know. Galileo was very interesting because, again, he dealt with all sorts of different things. You'll have heard about him dropping objects from the Leaning Tower of Pisa. But one of his biggest achievements was actually developing telescopes because, again, this built on the evidence that people were able to see. So not just with looking at the naked eye, you could actually see more objects. And this just reinforced the view that obviously the Earth was not the center of the universe. The Earth was actually traveling around the sun, and that the Earth was not the center of the universe. Again, the Catholic Church did their Inquisition, and I think actually after that Inquisition, they put him pretty much under house arrest for his views. So he sort of compromised.
Yes, they asked him to make a confession.
And it's very interesting to know that it wasn't actually until almost 350 years later, 1992, where he was actually forgiven. So it took the Catholic Church 350 years to admit that they were actually wrong. So you can see how some people are actually steeped in dogma. And they don't want to change their views because it benefits them. And if somebody comes along with something different because it challenges their theories, they'll do anything to prevent that and make sure that their theories are not overridden, even if the data... This goes back to what we were talking about in the first part, where the strong Christian evangelicals will always make up an excuse as to why they are right and why everybody else is wrong.
I know, and when he was under house arrest, in his confession, he sort of, whispered, "Oh, well, if you think it's fair enough, but I don't believe it."
He didn't really believe it. Yeah.
Words to that effect. But no, he was one of the great scientists, and of course, his your world view and the universe's view was inherited by Newton, who was again a great scientist.
Well, actually, before we come to the Newton, a number of developments had already taken place, and they were done at the back of the work of Galileo, as Arif has just alluded to, and not just basically observed the great planet Jupiter, as it were, but he also describes the spots on the sun. Yes, and obviously you can't look at the sun directly, and never mind you can't with a naked eye, and you can't look the sun through the telescope either. What he did was he placed a paper. And obviously, he will, when you place a paper, you can study the sun, and he will put various filters on it and so on. And he also describes craters on the moon and the 4 satellites of Jupiter. And that's basically proving that not everything orbits the Earth, and that was the main emphasis. And then, of course, he also promotes the Copernicus view of the sun-centered universe. And of course, as the power and the quality of telescope building increased, there was a chap called Christian Huygens. He studied further planets, the Saturn, and discovered its large satellites, Titan, and he also explained Saturn's appearance, suggesting that the planet is surrounded by a thin ring. And then we come to the 1663. There was a Scottish astronomer called James Gregory, and he basically made the Gregorian reflecting telescope using parabolic mirrors instead of the lenses, because lenses, they will basically cause shadows and aberrations, scattering of light. So basically you could not get good observational data, and so basically he will use parabolic mirrors. And then, of course, we have coming to Sir Isaac Newton in 1668. And the thing with Isaac Newton was he was a polymath, he was a physicist, and actually, Newton famously says that how come it is that I've been able to discover these things in my lifetime? It is because I stood on the shoulders of giants. And of course,
who were these giants? Go on, tell
he
me.
had an access to what we call the Book of Optics.
Yeah,
it's called Kitab al-Manzar.
Yeah.
It was written by, so when in the Renaissance, we tend to forget the contribution that Muslim scientists played a part to, and he had access to a book called the Book of Optics. And so we wonder, where did these optics came to Europe?
I mean, I deliberately avoided the Islamic contribution because we did that in the Islamic...
Newton did not avoid it. He mentioned it.
Yeah.
Obviously, he's not talking about Greco-Roman giants. They're long passed into history.
Yeah.
And
It was the
at
Muslim-
that time,
it was the
Renaissance
great Muslim
Europe had
science.
access to the book called the Book of Optics, the Kitab al-Manzar. And at that time, in the 16th century, in the 15th century, when you spoke of the physicist, they had the word the chemist, the physicist, the doctor, the physician. By the physician, they meant Ibn Sina, yes. By the physicist, the physicist. This was when the Europeans, and Newton himself used to say, the physicist, they meant Ibn al-Haytham, the father of the Book of Optics. And I think I just want to allude one thing, is a juicy bit for our audience. The people, even nowadays, they talk about Archimedes' famous mirror that he used to burn the fleet in Syracuse. That is lost to antiquity, except it is on the cover book of the Book of Optics, Kitab al-Manzar. That's how Europe and us, we got the idea. So let's not forget the great contribution that was made towards by optics, and the early basically work on on the rainbow, on the colors, and this is what actually Newton used. So here, yes, of course, we come into the 17th century. Newton builds the reflecting telescope, but of course Gregory builds the one using parabolic mirrors, which is a lot more accurate. We can do now observational studies. We can do experiments and look at these celestial bodies. And now, obviously, science is becoming. Before it was the paradigm of the clergy, the few. Now you can enroll into schools, and again the university system came by that into Germany, out of Al-Andalus and so on. Obviously southern Spain, the Moorish Spain, into Germany, into France, and
Again, his big contribution was also in understanding the role of gravity. And
absolutely,
celestial
using
bodies
mathematics and gravity.
Using mathematics and really the impact.
And I think his laws of physics as well, because obviously, again, in school, anybody that studies physics at some point, you're going to study Newton's laws of physics. And I think that helped overcome the residual opposition, you can say, because he was actually putting together laws, which could be tested, which could be measured, and which, he'd obviously spent a lot of time developing, and which are still, most of them are still as relevant today as they were in his time. And the part that Amjad mentioned is that obviously people started wanting to become more inquisitive and inquiring and find out from themselves, rather than being told to believe that, well, this is what you must believe. If all of these clever people are coming up with these laws and these theories, and they're intelligent human beings, why don't we check and why don't we investigate what they're doing, rather than just believing what we're told? And I think this accelerated the progress of understanding what was going on in the world.
Oh, absolutely. And now this is actually is a very important time. We can introduce the scientific method the observational data, tabulating things, using mathematics and geometry, classical mechanics.
We're going to cover a lot more of that in part 2 of our program. So moving on from Newton, but again, Newton inherited the eternal universe view. He was an interesting character with lots of different religious beliefs as well, but I want to go into that. But his view was, again, the universe is eternal, so it just carried on as it was. And then, of course, we move on to the world of Einstein and 20th century science and some of the big developments. We will, of course, we'll deal with the sort of biological evolution later on with Darwin, etc. But let's move on to, because sort of staying on cosmology and origins of the universe, Einstein. So he was a genius, clearly, but there was something that he missed out at the start, didn't he? Because when he was trying to talk about the universe and whether it was infinite, etc., he gave his famous formula of E is equal to mc squared, etc. And in trying to explain the origins of the universe, he put what was known as the cosmological constant to show, oh, there you are, I've sorted it all out. It's an eternal universe, etc. But Amjad, take us through it, because that was a big mistake of his life.
Well, before there are three, Einstein, when he graduated, obviously nobody will give him a job, and he was a bit of a misfit as well.
Yes.
With all these things, with all these ideas whirling in his head.
Universities turned him down. Incredible.
And he went for employment, and he went to a school, and he said, "Look, you can't teach anything." At the patent, as a clerk at the patent office. Yeah. So obviously, these classical mechanics and Newtonian laws and the Kepler's law as well of and Newton's three laws of the law of gravity and the laws of motion, and so F equals ma, which is force is mass times acceleration, and one of his laws is that two objects will attract two objects in the universe will attract each other with a force which is proportional to the radius and inversely proportional to their masses. So from F equals ma, we have F equals the big G, which is the gravitational constant. Big G, small g is the acceleration due to gravity, which is 9.81 meters per second. That's a small g.
God, he still remembers these figures.
So it's F equals ma, and then basically F equals ma, and then what we have is F equals G m1 m2 over r squared, and that is basically Newton's second law. And the third law is to equal, to every action there's an opposite and equal reaction. So those are three Newtonians. So everybody at that time, since the 17th century, grew up on diet of Newtonian physics. So here we come to Einstein, and he's a very interesting chap. So this famous apple falling on Newton's head, and he discovered gravity. Yeah. Well, when Einstein did his similar thought experiment, he said, I don't see anything falling like that. Nothing's falling on my head. Things seem to be not falling, things seem to be pushed down. He said there's no such thing as pulling, it's actually pushing. And people thought he was a nutter, really, literally, because things are falling, but he thought, no, things are not falling, things are being pushed. So where's this pushing coming from? He says, well, there's no such thing as gravity, there's no such thing, attracting each other. What it is basically the fabric of, he disagreed with one thing called the ether. He said, actually, this empty void of space is not filled with ether. It's actually the space itself is rather like a fabric we have, fabric of cloth, and it's the mass itself that actually causes indentation in space. Mass causes curvature.
Right.
Mass causes this space to curve itself, and it's the curvature of space that causes things to fall towards each other. Or so the Newton will observe. But it's actually not falling, it's being pushed down. So this is really a theory that really was the most revolutionary in itself. And then, of course, he used, and by the way, before we go to that, there are two other chaps in this story. One is, we probably heard of Gauss, a chap called Gauss, and Gauss was the first. He was an astronomer and a mathematician. Hence, we get this Gaussian curve that comes from mathematics, and we see that in our everyday life that flat space and so forth. He said, well, we have hills as well. So he came with three-dimensional space, and one of his brilliant pupils came up with curved space. So basically, Newton was blessed to have the mathematics there already of curved space and Newtonian calculus. So he used that to came up with this cosmological new constant, which basically said space space also expands. That's what his theory really alluded to. But he could not fathom the, expanding universe. It will basically be a chaotic universe until there's another chap, very famous chap, who looked through a telescope and he saw that the galaxies were receding.
Yeah. This comes on later on, obviously, to prove it. But the constant he introduced was really picked on by his student, Alexander Friedman, in 1922, when he said, boss, I think you've got this wrong. And that's when he withdrew it, and he said it was the greatest blunder of his life. And of course, now we know the formula.
Basically, the formula basically predicted that universe is expanding. But obviously, Einstein, doing all these crazy things in his mind, if he realized that if universe went on expanding forever, it'll come into nothingness.
I mean, one of the things that did this or put this in his mind was the fact that most scientists believed that matter could not be created or destroyed. This was a viewpoint before this century, and of course that later on, the atom got shattered and...
Well, before we get to the atom bit, there was another fascinating theory, and everybody believed that light was actually a wave. But Einstein's, when we do experiments, light is very dodgy. It behaves like a wave and a particle. So basically, Einstein came out with another clever theory. And he said, well, actually, light comes not as is not emitted continuously. It's actually emitted in pockets of energy, what he called quanta. So he revolutionized basically classical Newtonian mechanics. He also revolutionized quantum mechanics. Basically, and I think that's another field.
He's regarded as probably the greatest scientist of our time, isn't it, Arif?
And I think I think the point that we're trying to explain to our listeners here is that the theory about the universe being constant was obviously changed. Either it became that the universe was ever expanding, or that at some point it was going to contract. And even to this day, from what I understand, there are still people that will believe that it's going to carry on expanding. But there are lots of scientists that believe also that the universe will contract at some point. This will come on to the later program that we're going to make about the Big Bang Theory and the start of the universe. So there was definitely a shift from the fact that the universe was there. And as we said right at the beginning, that the universe even predated God in some creationist theories.
This was the biggest development that from a religious thinking and some philosophical thinking. Now the people are beginning to think that no, there was an origin, there was a creation moment, and that was the theory became as the Big Bang Theory, which we'll cover in more detail in the next program. And again, there are a variety of developments over time that proved that, and to this day we know. Quickly want to touch on the contribution of Darwin as well, because that shattered the known religious view and, the theological viewpoint. Adam was the first created man, etc. And Darwin, Amjad, do you want to say
Yeah, absolutely. He headed to the Galapagos Islands, and there he saw various birds and so on, and he basically figured out that things have not been static, things have been evolving and so on, and he came up with this wonderful theory of evolution, that things evolved on the planet, species have never been static. So he studied the pigeons as well, how selective breeding of the pigeons and so on. We've got the racing pigeons and different varieties, and also mammals as well. so the domestic animal husbandry. So all that observational and scientific data that he gathered, he said we couldn't have been static. So this basically revolutionized, well, that was before actually Einstein, but that it revolutionized biology and, human origin.
Well, I think it brings us really to the end of this first part of the program, where we've seen the journey from religious and philosophical beliefs of the universe being here forever to a viewpoint that no, it had a definite origin, a beginning, and things have changed, evolved, etc. In the next program, we're going to look at this in a lot more detail, and especially from an Islamic point of view, of how do we see science and religion? Are they compatible? Are they really going in different directions, etc.? So we hope you've enjoyed this program. Until the next program, it's goodbye from all of us. And don't forget to give us your feedback on Twitter. Our Twitter handle is at VI Living History. Until next time, Assalamu alaikum, goodbye.